In this demo, I'll show you how to tune a regression model distributedly on Spark and monitor the result in real time with mlflow. Let's take the California housing problem as an example. Recall that in this problem, we want to train both XGBoost and LetGBM with parameter tuning to get the best model. In this cell, we're defining the objective function and the search spaces. Before moving on to the tuning, let's do a quick check on the baseline scores using the default parameter values. So we can see that both of the models give a baseline score around 0.18. And now let's get to the tuning part. Fundamentally, we want to evaluate the objective function over a search space and get a model that gives the best result. In addition, we may want to apply a certain type of Bayesian optimization algorithm and distribute the tuning jobs on Spark to save some time. It would be great that if we can also monitor the tuning process in real time on mlflow. I'll pause here for a second and let's think about how we might normally design this workflow. And I will start typing my Fugue tune solution. First of all, I'll code the suggest for non-iterative objective function. And then I'll go over my task list. So starting from, I want to evaluate the objective function, which I have already defined above. And then I want to evaluate this over the search space I defined above. Here I have two spaces, one for XGBoost, one for LetGBM. And recall that in tune, we can use the plus operator to take the union of the two spaces. And next, I want to apply Optuna for Bayesian optimization. So I'll say local optimizer is Optuna. And I'll give it a max iteration number, say 50. And then I want to run this job distributedly on Spark. So I can say execution engine is Spark. And finally, I want to track the tuning result with mlflow. So I'll use mlflow as the logger or the logging method. And let's run this. So as you can see, this is really a simple and intuitive way to define a tuning flow. Now let's go to the experiment page to monitor the tuning result in real time. And here we can see a list of all the most recent parent runs. By parent run, they're corresponding to the suggested method we just coded. And we can click on the plus sign to look into each subruns. In this problem, the subrun may be a single model training for XGBoost on the gray search space. For example, these three. Or it's a Bayesian optimization on LetGBM. And we can also click into the subtrial that has a Bayesian optimization and look at the objective metric to see how it gets minimized over time by Bayesian optimization. Now, back to the summary page. We can monitor the best result over the entire training job simply by looking at the parent row. For example, for this most recent run we kicked off, we can read the best result from the parent row that the winner is LegGBM, and the best score is 0.17, where an estimator is 396.